We talked about exponential equations in grade 11, right? And we said an exponential equation is an equation that contains a variable in the exponent. So, I need full attention on me, please, right now. So if you remember, we're used to this. X squared, x to the power of 5, right? Y to the power of 5 over 2. In this case, the base is my variable. Okay? These are not exponential functions. Exponential functions are the functions where your exponent is the variable. So, 2 to the power of x equals 32, for example. So in this case, my variable is the exponent. Some exponential equations can be solved without technology by writing both sides of the equation as powers of the same base. So here's a question for you guys. This is the question here. 2 to the power of x equals 32. 32 is what? 32 is, can I write this as 2 to the power of 5? Is 2 to the power of 5 32? Yes. Yeah. 2 times 2 times 2 times 2 times 2 is 32. Now, if you look at this, 2 to the power of x equals 2 to the power of 5. What does that tell you? What's equal? Say that again. That means x equals 5. Why? Because I have the same base, right? If my bases are the same, therefore my exponents are the same. Yes? Does that make sense? Right? So basically, since this is the same, that right away makes the exponent the same. So in this case, what I did is I made the right side, right, to look like the left side, so I can solve for that exponent. You remember that? So this is the easy part. The easy part, if I can actually make the bases the same. And that only works if actually I have a number that when I raise it to the power of something gives me the answer. Okay? And if I have only integers and stuff like this. Okay, so that means x equals to 5, right? So I was able to solve in one step. So, if a to the power of m equal to a to the power of n, that tells me that m equals n, and that only works for all the numbers except a equals to 1, for all positive numbers. Okay? So a has to be greater than 0, and a cannot equal to 1. Why it can't equal to 1?
Because it doesn't matter how many times you square it, it's still going to be 1.
Yeah, so if I have 1 to the power of 1,000, it's going to actually equal to 1 to the power of 5, right? They're the same thing. 1 to the power of 1,000 is 1. 1 to the power of 5 is 1. But yet, 1,000 and 5 are not equal to each other, right? That's why my base cannot equal to 1. Now, since 4 to the power of x and 4 to the power of 3 are both powers of 4, the exponent must be equal, right? This is just an example here. So if I have 4 to the power of x equals to 4 to the power of 3, that means x is equal to 3. Now sometimes it's easy, it's given to me. Sometimes I have to like work for it. So 5 to the power of x equals to 5 to the power of 6. Solve for x. What day? X equals 6. You can drop the base and equal the exponent equal to each other. We just solved that one. 2 to the power of x equals 32. Right? So I would write it to the same base. And then drop the base, so x equals to 5. Are we all cool with that? Yeah.
Can you make the full step?
This is the full steps.
But is there any shortcut to find, like if it is, say, 84? How do we, is there any shortcut in?
Yes, there is, and I will teach it to you. What? That's it. These are the steps.
So yeah, you just write the numbers on the bottom and that's it, stay on the top.
So you have to make sure, look at the base. Okay, eyes on me, please. So we're always looking at what is my base on the one that's given to me, right? So if my base is 2, I'm going to have to, on the calculator, if I don't know what it is, I have to guess, right? So I'll go 2 to the power of 4. Oh, it's not. 2 to the power of 3. It's not. 2 to the power of 5. Oh, okay, it gave me 32. So I know it's 2 to the power of 5. And therefore, my exponents are the same. So in this case, we're just doing guess and check. As of now, it's the only way. No.
What if
No. We're not dividing. Okay?
what if the base were not equal?
Then your exponents are not equal.
And what's coming? You gonna explain that?
Okay. Don't worry. I'll answer all your questions as we go, okay? You want harder examples? They're coming. Okay, how about this one? 2 to the power of x equals to a half. 2 to the power of -1, do we agree? Can I change this to 2 to the power of -1?
Yes.
Why?
It's 1 over 2 to the power of 4.
What do we know about something like this? To make it positive, what do we do? Flip and make the exponent positive, no? Okay, I have the same base? I have the same base, so I can drop the base, and I'll have
So x is equal to
-1 over 2, right? I want to make it to the base of 2, so that means I want that to be in the numerator. The exponent here is 1, right? So I can change it to a base of 2 to the power of -1, right? We know that these are the same. Because if I have a negative exponent, I can flip my base and make the exponent positive. So I'm working backward here. I'm working from here to here. Working backward. Okay. Let's look at this. This is 1 over 4. I want my base to be 2. Well, the first thing I want to do is I want to change this 4 to a base of 2. What gives me 4? 2 to the power of what? 2 to the power of 2. To make it a base of 2, I have to flip and make my exponent negative. I'm working backward here, guys, okay? So I have the same base now?
Yeah.
I have the same base, so I can drop the base, and that means my exponent is negative 2. I love this. I love to hear this. Oh my God. Wait.
No, I already solved it.
You already solved it. Good. Okay. Who's going to solve the next one for me? What do I do? Raphael.
I just wanted to know what we should do in that now. I was about to ask you that. What we should do.
In order to solve for an exponent, what must you have on both sides?
Base.
Same base. So what's your base should be? What should your base be? 7. So your base should be 7. 7 to the power of what gives you 49?
7 to the power of 2.
Uh-huh. So, do I have the same base now? I love how you guys are light years ahead of me right now. So, drop the base. You guys have to slow down. Drop the base. Exponents are equal. Right? Because I have the same base, I can get rid of it. And I can make my exponents equal, like I did in the previous examples. But in this case, I'm not done. I have to keep going. I haven't solved for x yet. How do I solve for x? What do I need to do?
You isolate.
Isolate. Bring the 4 over. And then divide by 3. Take a minute to do the second one.